Have we been living inside a black hole all this time? Is our galaxy a part of a big black hole? The remarkable James Webb Space Telescope has unveiled a startling revelation about our cosmic address that shocked the entire space industry. Let's take a look into our newly acknowledged address. But before digging into the address part, let's first understand black holes. Black holes, those enigmatic regions of space where gravity reigns supreme, possess a captivating trait. They devour everything, including light, rendering them invisible to our naked eyes. Their presence can be detected through their profound influence on the surrounding matter. For instance, certain black holes exhibit swirling disks of gas and dust that emit intense radiation, known as quasars. These celestial marvels stand as some of the brightest objects in the universe, yet a rarer and more colossal variant exists: the supermassive black holes. The scariness of black holes depends on proximity. The gravitational force intensifies, causing time to slow down relative to someone far away. It is known as gravitational time dilation. Speculating about anything that predates it is deemed unscientific, as we lack the means to comprehend what reality was like before that monumental event. We are left without knowledge of what existed, its composition, or why it initiated to shape our universe. Such concepts remain beyond human comprehension. Some unconventional scientists challenge this perspective. They believe that before the Big Bang, all matter and energy of developing universes were compressed into an incredibly dense yet finite entity, often referred to as the seed of a new universe. This seed, though minuscule compared to anything observed by humans, possessed the extraordinary capability to trigger the creation of every other particle, along with galaxies, solar systems, planets, and individuals. If one were to assign the label of the God particle to something, this seed would be an excellent contender. One intriguing theory likens the seed of a universe to the seed of a plant, a core of essential material tightly compressed and hidden within a protective shell. And this is what occurs within a black hole. Black holes are remnants of massive stars that have exhausted their fuel. When such a star reaches this stage, its core collapses under the immense force of gravity, tearing apart everything in its path. Temperatures skyrocket to an astonishing 100 billion degrees Celsius, causing atoms and electrons to shatter. However, infinities are rare, and this discrepancy arises from the limitations of Einstein's ideas. While they provide remarkable calculations for most of the cosmos, they struggle to explain phenomena involving immense forces like those found within a black hole or during the birth of our universe. According to physicists like Dr. Poplawski, matter within a black hole can only be compressed to a certain extent. This seed, although incredibly small with the weight of billions of suns, is real and distinct from a singularity. Dr. Poplawski suggests that the compression process stops when black holes begin to spin rapidly at breakneck speeds, potentially approaching the speed of light. This rotation imparts a tremendous amount of torque to the compacted seed, making it not only small and dense, but also twisted and squeezed, akin to those coiled spring-loaded snakes in a can, which can unpredictably burst forth with a bang, an analogy that parallels the Big Bang. Dr. Poplawski prefers to refer to it as the Big Bounce. The seed of our mother universe might have experienced a tremendous bounce 13.8 billion years ago. Despite our universe rapidly expanding since then, we could still be hidden behind the event horizon of a black hole. Scientists believe countless younger black holes existed earlier in the universe, awaiting detection. Have we been living inside a black hole all this time? Black holes form when massive stars collapse, and their growth knows no bounds as they devour gas, dust, stars, and other black holes. The friction generated by this feeding frenzy heats the surrounding material, resulting in the emission of light observable by telescopes. These voracious entities are then transformed into active galactic nuclei, AGN, or the most extreme examples, quasars, which can be billions of times more massive than the Sun. Quasars unleash bursts of light, trillions of times brighter than the brightest stars, as they shed their gaseous cocoons. As scientists venture deeper into space, they intercept light from increasingly distant sources, affording them glimpses further back in time. By dissecting these subtle cosmic glimmers, they found a crucial clue. The heated material surrounding a black hole emitted faint traces of radiation. These findings have implications for the theory that our universe exists inside a black hole. Considering a two-dimensional black hole's event horizon, it should be smooth, which cannot support clumps of matter in 3 dimensions. Therefore, if our universe is a projection on the event horizon of a black hole, it should also exhibit smoothness rather than clumpiness. The holographic principle finds additional support from string theory, which suggests that fundamental particles are tiny vibrating strings existing in higher dimensional spaces. The vibrations of these strings determine the properties and interactions of particles. While the sudden appearance of black holes in the early universe remains a mystery, astronomers continue to search for primordial black holes that formed shortly after or even before the Big Bang. Two leading theories propose that black holes formed rapidly after the Big Bang. One suggests that they are remnants of giant stars that formed at an accelerated rate. The other proposes that collapsing clouds of dense gas led to forming these space-time singularities. This black hole then rapidly accreted material, causing it to grow to its observed size. Scientists will now search for stronger signatures of light from distant galaxies, particularly focusing on the emissions surrounding the mysterious black hole at the core of a galaxy. And it would be fascinating to see what they come up with. But the James Webb Telescope is yet to stop surprising us. It shows some evidence that we might be living inside a black hole. It recently observed two galaxies merging around a rare red quasar, a highly luminous and distant monster supermassive black hole. This discovery provides valuable insights into how early galaxies collided and shaped today's cosmos. The quasar, known as SDSS J165, 202.64 plus 172, 852.3, is approximately 11.5 billion years old and represents one of the most powerful observed from such a great distance. Hubble Space Telescope and the Gemini North Telescope in Hawaii initially scanned a specific region of space, identifying a quasar and suggesting a galaxy in a transitional phase. The subsequent observations with the JWST revealed not just one, but at least three galaxies orbiting the quasar. Scientists had previously suspected interactions and mergers based on the altered shapes of the galaxies, but the JWST data left them perplexed. They spent weeks meticulously studying the photographs, trying to comprehend what they witnessed. Even a concentrated knot of dark matter couldn't explain this phenomenon. The researchers proposed that they may be witnessing the emergence of two massive halos of dark matter, an unexpected revelation. Moving forward, the scientists aim to delve deeper into this intriguing galaxy cluster. They emphasize that what we see in the data is just a fraction of what it holds, with overwhelming complexity and surprises. Each blob in the images represents a merging baby galaxy into a larger mother galaxy, and the colors depict different velocities, showcasing the intricate motions at play. Studying neighboring galaxies like Stephan's quintet allows scientists to closely observe how interactions between galaxies stimulate star formation and disrupt the gas within them. Such close groupings may have been more common in the early universe, particularly when fueled by quasars, superheated black holes that were highly active. NGC 7319, the top galaxy in the group, houses an active galactic center with a supermassive black hole 24 million times the mass of the Sun, emitting light energy equivalent to 40 billion suns. The JWST captured a vast sea of thousands of distant background galaxies, akin to Hubble's deep fields. Combining the data from the JWST with infrared images from MIRI and the NIRCam will provide essential new insights. These observations will enhance our understanding of supermassive black hole feeding rates, growth processes, and star-forming regions. The results from studying ancient and dormant galaxies have provided evidence that black holes are expanding faster than expected, aligning with a phenomenon predicted by Einstein's theory of gravity. These findings suggest that dark energy has puzzled cosmologists and theoretical physicists for over 20 years and requires no new elements to be added to our understanding of the cosmos. The expansion of the universe discovered in the 1990s revealed that objects are moving away from each other at an accelerating pace, contrary to expectations based on gravitational attraction. Dark energy was proposed as a force pushing things apart more forcefully than gravity. This concept drew on Einstein's abandoned idea of a cosmological constant, which counteracted gravity to prevent the collapse of the cosmos. The discovery of the universe's rapid expansion revived this concept, attributing it to vacuum energy embedded in space-time. Black holes posed a challenge to this explanation due to their intense gravity and the formation of singularities at their centers, where the laws of physics break down. The new findings indicate that black holes gain mass in a way consistent with possessing vacuum energy, thereby serving as a source of dark energy and eliminating the need for singularities. The research involved studying the evolution of black holes over 9 billion years. Supermassive black holes are discovered at the centers of galaxies, containing millions to billions of times the mass of our Sun and exhibiting extremely powerful gravity. All these pieces of evidence point toward a holographic universe residing on the event horizon of a black hole. As we delve deeper into space and expand our knowledge, these theories challenge our understanding of reality and open up new realms of exploration. Subscribe to channel for more blues from the celestial world. Living inside a black hole carries profound implications, offering fresh perspectives and expanding our comprehension of the vast cosmos. So, when you gaze at the night sky and contemplate the mysteries that lie beyond, remember that the universe might hold secrets we are just beginning to uncover. A reality projected onto the vast expanse of a black hole. This video popping on your screen will unravel more brilliant discoveries of the JWST.